Continue on with slope fields. We call the differential equation, we have to be able to separate this. We won't focus on that so much though right now. We'll look at another one. This slope field is different because it has both the x and the y. So this isn't a function, right? It's a relationship, though. It's a relation that we'll play around with. Now, to do this, don't just try looking at them right now. You wouldn't have the knack necessarily. Good gravy. Now, I would suggest you do a few of these in chart form. Let's try when y equals 0. Use easy numbers. Now, why did I choose 0? 0 is going to be easy. When y equals 0, what is it? Which axis? It's the x-axis when y equals 0, right? Y equals 0 here, here, agreed? Here. That's what we're really figuring out what the slope lines are, all along those dots. So, when y equals 0, let's figure out dy by dx using that equation. It'll be x minus 0, right? Okay. Now I'm going to just do a little t-chart kind of. I guess I'm doing it right to left the way I set this up. No, sorry. Excuse me. I'm going to put it like this so I don't put my x's here. It's a bad way to organize it. Now it looks like I got negative 3, 2, 1, 0, 1, 2, 3. So I'll start with negative 3. Now, we have negative 3 minus 0, right? Negative 2 minus 0. Okay, you get the pattern, right? Okay, dot, dot, dot. And I'll go to 3. 3 minus 0. That means, using this equation, x minus, and I used 0, all along the x-axis. Well, let's start with the easiest one. It's at 0, x equals, when x equals 0, we got a slope of 0. I'm doing this because I want to work away. When x equals 1, the slope is 1, right? Now, that's 45 degrees. When x equals 2, the slope is 2. That's going to be steeper than this, right? When x equals 3, it's got to be steeper, but it's not straight up and down, but a slope of 3. My 2 and 3 doesn't look that great. I'll just make sure. Your 1 should always look 45-ish, and that's not hard to accomplish. It's differentiating and not making things look different between the... Okay, so do you guys see what we did there? Okay, now backwards, when we have negative 1, we have a slope of negative 1. We have a slope of negative 2 and a negative 3. Make them gradually steeper in the negative direction, right? Now let's try this when y equals 1. When y equals 1, so we're talking about this line here, right? When y equals 1, what do we got? So I'll set up the chart similar to before. I'll just put dy by dx equals x. In this case, the y is 1, so x minus 1. Let's plug in a few numbers. Negative 3. Negative 3 minus 1, though. Negative 4, right? Negative 2 minus 1 is negative 3. And blah, blah, blah. We end off, I'll do 2 in a row. 2 minus 1 is 1. 3 minus 1 is 2. You guys kind of see where this is coming from? Okay. I want to show you, this will be really steep. This will be steep-ish. Should be, now I'm going to shake that one off there. really and truly, this one should be just as steep as the other one, right? If this is -3, this is -3, right? Now, I'm not going to get out a protractor and see perfectly, but you have to make sure things look steep when they're -3s. But when it's -1 or +1, make sure that looks 45 degrees-ish. So, this one here, that'll be the answer there. Then we've got -1, and we have 0. 0 minus 1. 1 minus 1 is 0. And then a little bit steeper. Okay. Let's just think something through here. Where will you get slopes of 0 all the time? Y equals x. So when you have 1 and 1, x, we got 0. When you had 2 and 2 in here, you'll get 0, right? Always look for easy ones to put in here. Now I'm going to do the rest of these in just green. Okay. So I know that this spot, which represents 2, 2, 2 minus 2, -1 minus -1, -2, okay. Now this helps a pattern emerge. See how this kind of is on a diagonal line here, right? The zeros. Just from what we did here, and I made sure that when I traced this, I traced this one here and said that's the same slope as that. If you were to do a line of y equals 2 values, do you see that? When you plug in -1, -1 minus 2, you get that -3 again, wouldn't you? So you'd end up getting this spot here. Now, without calculating, can you see by that same pattern, you'd get this one over here. This guy here would be mighty steep. This guy over here would be a -2. This would be a -1, +1. Off a little bit, but oh well. You can extend that pattern all the way through then. And if you don't see the pattern, just choose then, well, what is it when y equals 1? -1. Y equals -2. But by extending the pattern, you should be able to see those things. Where was I now? Okay, I'm going to just do all these 1s here. Then I'm going to do all these -1s here. I'll do the easy ones. Then I got a little steeper here. Then I've got this here. Then even steeper here. Okay, and it gets so silly steep here that it's just, I can't really draw those that accurately, can I? Well, kind of can. But it's hard to draw this corner here. The bottom right corner is hard. Now, what kind of function does that suggest? Let's choose the spot where, well, the function may be at -1, 0 as a spot, and we'll trace the actual solution. It doesn't ask that. Trace the solution that has this particular value, that includes -1, 0. So this means this is my starting point, eh? -1 and 0. What does that suggest happens? Let's go backwards to the left. Kind of looks like it would go upish, right? So, and then to the right, like I'm going to try to draw this all. I'll use disappearing. Kind of looks like here, and then to here, and then it must get super steep. Okay, that's going to disappear. What about as it go to the right, though? Even though there isn't one right here, we can imagine somewhere in here there would be a 0 line, right? So it's going to somehow then go here, and then this must be like a angled asymptote, right? So this particular solution here, if I have to include -1, 0, I'm going to just kind of Is that kind of, I guess I was going to use black for this here. Let's see if I delete the right thing. Just so you can see the difference here. Is that sort of what that suggests? Now there's many solutions here, right? This could also suggest this solution here, you know what I mean? Solutions all the way along here fit this pattern, don't they? I just asked for this particular one. Then you could have other solutions that are below the diagonal asymptote line, right? You could have ones down here that kind of like suggest this kind of a pattern, doesn't it? Okay. But that's just one particular solution there. We'll get used to this idea and I'll give you some to sketch these. How about the slope field from the derivative equaling x, y, that relationship? Well, let's try it when x, let's try it with y equals 1. When y equals 1, x. Then the derivative values would be x times 1. So they're going to be a direct match, right? Negative 3 will give me negative 3. Negative 2 will give me negative 2. All the way up to 3. Okay, that's going to be easy, right? Let's try that. We'll just plot those ones on here real quick, like. So at the line y equals 1, so just above the x-axis. Start at negative 3, make it super steep, medium steep, negative 1 as a 45er, a 0, at 0, 1 at 1. Okay. Let's think of some easy ones though right now too. Zeros are the easiest to evaluate when you have x times y. Whenever y equals 0, all of the intercepts will be 0. So I know I have 0 sitting here right on the axis. And whenever x equals 0, it'll be 0 times whatever, right? I don't need to do a chart to do that. And after a while, you don't necessarily need a chart. So I like to think of when y equals. So when y equals negative 1, what do we get? Well, if I put in, so I'm going to go with this line right here, bless you. When y equals negative 1. Negative 1 for the x value will give me a positive 1. And then 2. And 3. Positive x values, so like positive 1 times the negative 1 for the y. And then steeper. You get the idea. Now the 2's get even, well, they double up all the slopes, right? So that's when y equals 2 up above. Negative 3, well, that'll be negative 6, negative 4, negative 2, and so on. Negative 6, negative 4, negative 2. Okay, and do you notice how above the x-axis, below the x-axis, it kind of looks like a mirror image, if you can kind of make that look that way. So, steeper, negative 2, or positive 2, my mistake. Try to get the right steepness on this. And, sort of like this, right? That's a series of slope lines. What does this suggest? If you had a solution that was including a y value above 0, so greater than 0, this kind of looks like this family of curves, this, or this one, or etc., right? And below, if I said use solutions that include negative values for y, well, those would be, you'd have this one, depending if I said specifically use 2 comma negative 1, you would start on this point and then say, yeah, this looks like it would 0 out here, and then, you know, some kind of rainbow like that. Okay? Now, is there any questions about this at this point in time? Sometimes it's easiest to look for the zeros on these things. Where will you get zeros on that, x minus y? I think we just graphed that, didn't we? Yeah, that was what we graphed. But without looking back. When 1 comma 1, 2 comma 2, negative 3 comma negative 3, right? That's where you're going to get zeros. We have 1 minus 1, 2 minus 2, etc. So you're looking for zeros somewhere on the diagonal. Now, looking at these, there isn't a clear-cut choice, but do you see that between here and here, there must have been a 0 in between there, right? Like a flat line. There must have been a 0 about here. There must have. Do you sort of see what I'm talking about there? How else could it have gotten? This is the only one that seems to have that feature. So if you can find one thing that's distinct, first try, you can identify which one it is. And quite often you'll have, basically what you're likely to have is either one picture of a slope field, and you're supposed to match it up with these one of the 4 choices, or the other way around is one equation, differential equation given in 4 pictures, and you got to match it up if it's a multiple choice question. We just played around with this, and that means that you're looking for somewhere where you got 0 on the x-axis and the y-axis, right? Now, zeros are here, but what about the y-axis? Doesn't look like that, does it? Looks like it's infinite. As a matter of fact, there's no value for there because you can't have an infinite slope, because that means you would be dividing by. Let's just scan these and see which one this would be. Here, like with all these zeros here. You can't divide by zeros when y equals 0. You have no value on that one. Let's skip order. That would be number 3, as you said. Okay? A would be number 3. So there must be another one. This has the zeros here, right? And this looks like it's coming to a 0 along the y-axis, doesn't it? Shardu? D? What do you notice about this? Now, obviously, C, but when you look at this, where are you going to have undefined values? Yeah. So it makes sense that y's are all zeros, but when x equals 0, you would have an infinite slope, and that's not going to show up. It's undefined. That's why C would be the answer to this. All of those little slopes, consider them all one at a time. Okay? Now this ABCD, the sketches, they didn't give you 1, 2, 3, 4, like as far as points. So you had to use some guesstimations, and sometimes the actual zeros didn't appear on that. Now, there's some work for you guys to try.